I don't even know if you can see this, but really fast, I want to try to go over some of the more difficult balancing equation problems in Adrian Dingle. So this is from topic 5, I believe it's page 11. Anyway, it's balancing a redox equation using the half cell, or the half reaction, method. And I wanted to start with the ones that you guys thought were a little bit difficult. So we're going to start with this one. This is A. And what we have here is we have what's interesting about this is it is a disproportionation reaction. What we have is the same element, iodine, being both oxidized and reduced. So I'm going to show you a way to go ahead and balance this by splitting them both in half. So first thing to think of is, what are my oxidation numbers? Here I know oxygen is a -2, and there are 3 of them. So this whole molecule is going to add up to -1 for the oxidation state, and then the oxygen is going to be a -2 times a 3 is a -6, and I have to figure out iodine. So iodine here, the oxidation number is going to be a +5. Okay, that's this one. This one is a -1 because we can see that the charge is the oxidation number. It's a single element. Now jumping over here, I have both iodines at a charge of 0. Or an oxidation number, of 0, okay? So it's this iodine that is actually being reduced, and it's this iodine that's actually being oxidized, and that's a little bit tricky to balance, but we still do it the exact same way we balance other redox reactions. So first thing we're gonna do is we're gonna break it off into half reaction. I'm gonna write iO3 negative, and I'm gonna leave a whole big space for myself, and then here, it's only one of these iodines that I'm referring to. So in this case, this iodine is actually being reduced. I only want one of the I2, so I'm going to write 1/2 I2. Do you see how I did that? That was the lump that most of us got stuck on. And then I have to figure out where are these electrons going. Now, this is a 0 charge, right? And here it's a +5. So I'm going to go ahead and add 5 electrons, because that's what added to it in order for it to get reduced. Okay, that's my first half reaction. This will be the reduction. Okay, then the second thing I want to do is I want to worry about the reaction that was oxidized. Okay, that was the the I negative, which is iodide, and I'm going to do the same thing I did. I'm just going to leave a big space, write my arrow, and I'm going to put the other half of that, 1/2 I2, which is a 0 charge, okay? Now this iodide actually lost 1 electron because he's going from -1 to 0. So I'm going to go ahead and I'm going to add that electron that he lost here to this side, okay? Now, what I can do is I'm ready to actually start balancing my electrons here. I can do this in many different ways. I'm going to go ahead and balance the electrons first because I feel like it. Anyway, in order to balance this below, I want basically these 2 reactions to add or subtract in such a way where my electrons cancel. So I'm going to have to multiply the bottom reaction by 5. I'm going to have 5 iodides make here 5 halves of iodine plus 5 electrons. Okay, and now that's how far I've gotten so far. Now what I'm going to do is my electrons cancel. I'm going to go ahead and just bring everything down. I have 5I minus plus iO3 negative. I'm going to keep my arrow. Now I have 1/2 plus 5 halves. That is 6 halves, aka 3 iodines. And that's it, no electrons, okay? Now, you might be wondering why up here the reaction has water and then just these random protons. And we do this in order to balance out the oxygen. So my last step is here. When I'm looking at my little reaction, I have 3 oxygens here. And there's nothing on this side. So what I'm going to do is I'm going to add 3 waters. 3 H2Os, okay? So the last step, I'm going to balance out the second to last step, I'm going to balance out my oxygen, okay? Now I have 3 waters, but now I have 6 hydrogens on this side that I don't have on the other side. So I'm going to put plus 6 protons, okay? And that is my final reaction. And close up to the screen, okay? And that's how we balance that one. Now, I want to go ahead and do another one, and then I'll end the video to try to keep it short. This is another reaction. This is B on Adrian Dingle's, again, page 11, topic 5 from the notes. And what I have is I have iodine plus, now look very closely here at this. Okay, you can see the reaction. I'm gonna break it up the exact same way I did the last. I'm gonna break it up into two half reactions. The first one I'm gonna write is the iodine just because it's the closest. And I'm just gonna go ahead and say I have I2, I'm gonna put my arrow and it becomes iodide. Okay, so that's all I did. And then it's going from a 0 oxidation number to a -1 oxidation number. And first of all, I actually have 2 of these. 2. There, I'm balancing out my little atoms first. So I have, it goes, both of these iodines go from a 0 oxidation number to iodide, which is a -1. So that means in order for that to happen, it actually has to gain 2 electrons. So I'm finished with that reaction for now, the half reaction. Now what I'm gonna do, I'm gonna bring down the reaction, excuse me, the oxidation half reaction, S4O6 to negative. Okay. Now what I'm going to go ahead and do is I'm going to first balance out my atoms. I have 4 sulfurs and 6 oxygens on this side. I only have 2 sulfur and 3 oxygens on this side. So I'm just going to go ahead and, yeah, the honest truth is, well, I'm going to go ahead and put 2. I don't actually have to do this yet, but whatever. That's what I'm going to do. Okay, now what I'm going to do is, and this is going to look really ugly, so bear with me. What I'm going to do is I'm going to figure out what the oxidation numbers of sulfur is. In this case, the whole thing adds and subtracts up to a -2. Oxygen, I have 3 of them in this molecule, and oxygen is a -2, so that would be -6. And I have 2 sulfur, so it's basically 2x minus 6 equals -2. Okay, and if I solve this, I add the 6 to both sides, I wound up with 2x equals +4, so therefore x is equal to 2. Sulfur is a +2 on this compound, okay? Now, when I look at this one, this is where it gets ugly. I have, the whole thing adds or subtracts up to a -2 as well. And I have 6 oxygens. Every oxygen is a -2. It's a -12. And I have 4 sulfurs. So I have 4x minus 12 equals a -2. I'm going to add a 12 to both sides. I wind up with 4x equals 10. So therefore on this side, see how ugly it gets? X, or the oxidation number of sulfur, is going to show as 10 divided by 4, or rather 5/2, okay, plus 5/2. Now, the truth of the matter is this is not reality. The truth is 2 of these sulfurs are probably like an oxidation number of, +2, and 2 of them are probably a 0. But we don't really care about reality. We're going to keep with my math because I can get this to work out appropriately if I do this. So I'm just going to keep holding on. Now, if I want to figure out what changed in the electrons between 2 and 5/2, I can't do that unless I convert this to, I want the same lowest common denominator. So 2 would be the same thing as +4 divided by 2. Okay, you didn't see Susie. She just got a sticky note stuck to her butt and ran away. But anyway, so I have 4 plus a +4/2 and a +5/2, which basically it looks like, according to what I've drawn here, every single electron, every single sulfur has actually lost 1/2 of an electron. 4/2, 5/2. So I'm going to put just a 1/2 just temporarily. But the reason why this 1/2 is wrong is because look at how many sulfurs I have. I have 4. Okay, I have 4 on this side, I have 4 on this side. So what is 4 times 1/2? It's 2. Do you see how I got that? Okay? That one was really ugly and it was really tricky and it took a little bit of brain power, but I still worked it out the exact same way I normally do. Now, I still do the exact same thing I normally do. Both of these reactions, I have balanced the actual elements, check, and I've balanced the electrons in each half reaction, check. Now the only thing left to do is to check and see if I add these 2 reactions, are my electrons going to cancel? I have 2 here and I have 2 here. Yes, they are going to cancel. So I'm just going to go ahead and cancel those electrons and then add up what I have left. I wind up with I2 plus 2 S2O3 with a -2 charge. And then I have my arrow and I have 2 I negative plus S4O6 to negative. At the bottom is my final answer. Okay, now these were a lot trickier than the ones that we did in class, so I'm glad that I had the opportunity to make this video. Anyway, if you still need help with C, D, and E, Try them, practice them. If you still need help, let me know and I'll help you out. You can come see me after class, inshallah. Anyway, I hope this helps for now. Good luck, ladies, and let me know how you do.